Now we've seen addition and subtraction of polynomials. Now let's look at multiplication. The basic idea is that the property of exponent, which we can see here with an example, 2 cubed means it's 2 times 2 times 2 3 times, and 2 to the 4 means it's 2 times 2 times 2 times 2. So that 2 cubed times 2 to the 4 would be 2 to the 7, which is 2 to the 3 plus 4. So what we see here is that exponents add up when multiplied. Since x, y, and z represent numbers, the same must be true for them. So for example, x squared times x cubed is x to the 5. X times x is x to the 1 plus 1, which is x squared. Now let's look at multiplication of two functions, 2x squared minus x plus 1 and x squared minus x minus 1. In the first step, we are going to use distribution. So here, Here, the 2x squared multiplies with all of the second term, minus x with all of the second term, plus 1 with all of the second term. And then we distribute again. So 2x squared times x squared minus 2x squared times x minus 2x squared. After distribution, you can use the exponent property and add the exponents up. And then, now the problem has reduced to addition and subtraction of polynomials, which we already know how to do. That is by collecting the like terms. Just be sure that you are distributing this negative here. When you do that, all the positive terms become negative and the negative terms become positive. And you end up with this particular expression. There are some special products that you should be aware of. The difference of two numbers times the sum of two numbers is the difference of their squares. The same sum of two things multiplied with itself gives you a squared plus 2ab plus b squared, and a minus b gives you the same expression with a negative 2ab. Now, for example, let's say there is a polynomial 5x plus 5, 7x plus 5 plus 4y, 7x plus 5 minus 4y. Now, you could be a little smart about this and notice that these are in the form of a plus b and a minus b, and thus it becomes a squared minus b squared, which you can then use the a squared a plus b whole squared to evaluate the first term, to give you 7x, it's whole squared, so make sure it's whole squared, which means 7 is squared as well, so you get 49x squared. Similarly, it's 4y squared, so it's 16y squared, and so on. Now I'm going to introduce an area interpretation of algebra, which we will be following through with other methods in this particular video or series of videos. Now recall that the area of the rectangle is given by length times width. Now a plus b whole squared means I have a length a, I add b to it, and I have a width a and I add b to it. Now the construction here shows you that there are four small rectangles, and what's written inside is the area of the rectangle. So this small rectangle is area a squared. These two are ABs, and the green one is b squared. Now, the area of the big rectangle must equal the sum of the area of the small rectangles. And the area of the big rectangle we know is a plus b whole squared. And the sum is a squared plus 2ab plus b squared, and then you have your identity. So here's a bonus problem. Can you show a similar explanation, meaning an area explanation for a minus b squared being a squared minus 2ab plus b squared, and a plus b times a minus b being a squared minus b squared, which is a more challenging problem as compared to the first one. An example application of this formula: a to the n plus 4b to the n squared gives you the following result. We use this property, that is a to the power m whole raised to n becomes a to the power m times n, or the exponents multiply. Example: 2 cubed to the 4 is 2 to the 3 times 4, giving you 2 to the 12. Concept check here. Can you verify that this always works? It's very simple. Just try to expand this 2 cubed to the power 4, and you will see why the exponents get multiplied. Now, continuing with our area analogy, There's a visual way to carry out polynomial multiplication using the concept of areas. For example, 2x plus 1 times x plus 3 can be drawn as following: 2x, 1 on the x-axis, x, 3 on the y-axis, and you make these boxes. Now, the idea is that the area of the bigger rectangle, which is what we are trying to find, should be the sum of the small rectangles. And you can place the area of each of the smaller rectangles as marked by purple here: 2x squared, 6x, 3, and an x. And that's when you add it up, you get the multiplication. To make the process faster, you can just use a single color. You can form columns and add these up, as in this example. You can even extend it to trinomials, except now you're going to have a 3 by 3, so you're going to have 9 squares to add up. It becomes cumbersome with more terms, but it should give you a visual cue about what it means to distribute or to FOIL. So that's the end of this part.